All right, so we have a solution containing acetic acid and acetate, and we're told it's a buffer. So we're asked some questions about it being its pH, and then its pH after we add HCl and then NaOH. Okay. Now first, let's just make sure this is a buffer. Okay. This is CH3CO2H, acetic acid. It has a Ka of 1.8 times 10 to the minus 5. This is a small number. That means that this is a weak acid. Okay? As an acid, it loses an H plus and it becomes CH3CO2 minus. This is my weak base. Okay? So I have a weak acid and its conjugate weak base, so I have a buffer. All right, so if I want to go ahead and I want to answer questions about pH, I can use the Henderson-Hasselbalch equation. Okay, so at the beginning we're asked for its pH. So we're told that we know that pH equals pKa plus log of A minus over HA. Now these can either be moles or concentration. In this case, see, now we have moles, we're going to use moles. All right, so my pKa is negative log of 1.8 times 10 to the minus 5. My A minus, that's my base. And 0.24, that's my acid. All right, so I have 1.8 times 10 to the minus 5. I'm going to do log of that, so this is 4.74 plus log of 0.35 over 0.24. This is log of 1.46. Okay, so when I do that, I get 0.16. So that's going to get me a pH of 4.90. It doesn't have units because pH never has units. Okay, so this is my starting pH. It makes sense that it's bigger than the pKa because notice I have more base. If I have more base than acid, then I'm going to have something that's more basic. All right, so my pH at the very beginning is 4.90. We're going to come back and we're going to use Henderson-Hasselbalch in problem 2 and 3. All right, so number 2, I add 0.05 mole of HCl. HCl is just there to produce H plus. Okay, so I have H plus I'm going to add. Okay, this is an acid. So what does my acid react with? Does it react with my acid or with my base? It's going to react with my base. Okay, so I have H plus my base. And when these two come together, they're going to get me the other component of my buffer, that weak acid. Okay, so I have 0.05 here. I have 0.035 here. I have 0.24. That's what I have initially. What do buffers do? Buffers remove any H plus or OH minus added. So that means they're going to take all of this away. So if this decreases, this also decreases. And if this decreases, my products increase. It's going to get me 0 for this. This is going to become 0.3. And this is going to become 0.29. Okay? So now I have still my buffer. I have my weak base and my weak acid. So now my pH is going to be the pKa, which we had found earlier is 4.74. I'm just going to write that here because we're going to use this a little bit. All right, and then I'm going to add the log of my base over my acid. That's going to get me 4.74 plus 0.01. So that's going to get me 4.75 for my pH. Okay? So when I added acid, I got 4.75. That makes sense because I start off at 4.9. If I add acid, it makes sense that my pH decreases. Okay, let's do part 3. Part 3 is I add 0.02 moles of NaOH. NaOH is a strong acid base, and it's going to produce OH minus. So my OH minus, which is a base, it's going to react with my acid. So I have OH minus plus the CH3 CO2H going to form CH3 CO2 minus. Why? Because this OH minus, it's going to strip an H plus from here, and that's going to produce H2O. All right, so initially I have 0.02 moles of this. I have 0.24 moles of this. I have 0.35 moles of my base, and I don't care about the water. Okay? All right. My change, right? Well, all of this goes away. So seeing that this decreases, this also decreases, and then this increases. That's going to be 0. This is going to become 0.22. And this is going to become 0.37. Okay? All right, so now my pH equals my pKa plus the log of my base over my acid. That's going to get me 4.74 plus 0.23. That's going to get me 4.97. Does this make sense? I added base, so it makes sense that my pH actually increases. Okay, it would start off at 4.9, then it went to 4.97. Let's go ahead and look at these on the screen. Okay, so when I just have a buffer, I can use Henderson-Hasselbalch. But once I start adding in acid or base, in this case in number 2 I added in acid, I need to remember what's going to happen. My acid is going to react with my base. I get new concentrations of my buffer components. I plug those back into the Henderson-Hasselbalch and I get my pH. The same thing goes in step 3 when now I'm adding in OH minus in there. All right. Now my base that I added reacts with acid. Okay. All right. Now let's go ahead and let's look at another aspect of buffers. Let's figure out which of a mixture of acids and bases is best to prepare a pH 9 buffer. Okay. So, there are 2 things we learn when we want to create a buffer. Okay? The first thing is that the pKa of my weak acid should be close to the buffer I want. In this case, that's pH 9. The second thing is that I want a ratio of acid to base of about 1 to 1. Okay? This just means if I have a 1 to 1 ratio, it has more buffer capacity, right? It won't, it'll stay a buffer longer. All right, so let's look at these. A. In A, I have HNO3, and I have NO3 minus, okay? Well, HNO3, I have a Ka of 28. That's a big number, okay? This is a strong acid. If it's a strong acid, that means it's not a buffer. So this would be a bad choice for my buffer. All right, let's look at B. In B, I have NH4 plus and NH3. This is 0.5 molar. All right, I'm told that the Ka of NH4 plus is 6.3 times 10 to the minus 10. If I want to figure out the pKa of this, it'll be negative log of this, 6.3 times 10 to the negative 10. That's going to get me 9.2. Okay. That's fairly close to the pH I want. So maybe this is a good contender. So we'll just put that down there. And we'll come back to this one. All right. C is the same two acid and base, except now I have different concentrations. Okay. So I still have a pKa, seeing that the Ka is the same of 9.2. Let's come back to these. Let's see if D is better. Okay. D is H2CO3 2 okay, and HCO2 minus. We're told the Ka here is equal to 1.8 times 10 to the minus 4. That means the pKa, which is negative log of that, is going to be 3.7. The pKa is 3.7. We want pH 9, so this is a bad choice. Okay. All right, so A was a bad choice because it's not a buffer. D is a bad choice because the pKa is not close to pH. But let's look at B and C. B and C are the same acid and base, ammonium and ammonia. But look at the ratio. Here I have 0.5 to 0.1. So I have 5 for every 1. In this one, I have 0.5 to 0.6. So that means I have 5 for every 6. This is closer to a 1-to-1 ratio, right? Another way to think of this is 5 over 6. That's going to get me 0.83, right? Whereas 5 over 1, that's going to get me 5, right? This is closer to 1-to-1. So that means that C is my best choice. Okay. Here it is on the screen, right? We can see we start off by figuring out whether it's a buffer, that knocked out number or letter A. Then we figured out the pKa's, right? That knocked out D because it was too far away. And then we choose the buffer that has a ratio closer to 1-to-1. All right, that's it for buffers. Now let's go ahead and let's look at a titration curve, right? Remember, a titration curve is when I have an acid and a base coming together. Okay. All right, so we're told we have 2.035. All right, so the best thing to do whenever you have an acid and base coming together is just write down everything you know about the acid and everything you know about the base. Okay? So we have 2.035 grams of acid. Okay? What else do we know about the acid? We know 100 mLs. Okay. What do we know about the base? We know it's 1 molar NaOH. That's a strong base. Okay, this is a strong acid because it tells us it's a strong acid. Okay, what else do we know? We're told the equivalence point. Well, what is that equivalence point? Is that acid or base? Well, equivalence point is always when we add in our titrant. Okay, so I've added in 32.3 mLs. So my titrant in this case is the one with the known concentration. So that means that that is for my NaOH. Okay. All right. So I know some information about the base, some information about the acid. Let's go ahead and answer the questions. All right. So we're asked how many moles of acid are there? Well, we don't have enough information here, but remember what equivalence point means. Equivalence point is the point where moles acid equals moles base. So if I know the moles of base, I can figure out moles acid. Well, I have a concentration and a volume here, so I can use these two to figure out a moles. So moles base equals the concentration times the number of liters. That's going to be 0.0323 moles NaOH. Okay? In seeing that moles acid equals moles base at it, that means I have 0.0323 moles of my acid. Okay? I use the fact that at the equivalence point, moles acid equals moles base. Okay? All right, let's go ahead and write that up here. Okay. Our second thing, what is the concentration of the acid? So we want to know concentration of the acid. So that's going to be moles over liters, because that's what concentration is. I just figure out the moles. I was given the number of liters. This is just of the acid, right? So it's moles acid over liters acid. Nothing to do with the base. All right, so when I do this, I get 0.323 molar. Okay, that is the concentration of my acid. All right, the third question, what is the molar mass of the acid, right? Remember all the way back to 215, the most important thing, stoichiometry is number one. Second, molar mass, right? Molar mass is grams per mole of the acid. So I have 2.035 grams over 0.0323 moles, and that's going to get me my molar mass. 63.0 grams per mole. All right, now the last thing it asks is to draw a sketch of the titration curve. Okay. Well, first, whenever I ask for a titration curve, it's going to look something like this: pH versus mLs of the titrant. Okay. And I'm either going to start at low pH or high pH. What am I going to start out with here? Well, my acid, that's my analyte. It's my analyte because I didn't know its concentration. I knew the concentration of my base, so that's my titrant. And my analyte is what I start off with. So if I start off with a strong acid, I'm going to start off at low pH. And then I'm going to add in base. So it's going to increase. And it's going to increase very fast near here. This is the equivalence point. And the equivalence point is going to be at exactly 7. Okay? And this point down here, 32.3 mLs, that's where my equivalence point is. pH 7 and 32.3 mLs titrant. Okay? All right. So here it is on the table, right? The first thing I have to do is I need to realize that, hey, my calibrate or my titration curve, this tells me where moles acid equals moles base. So I had enough information to find moles base, so I used that to find moles acid. Okay. Then I figured out the concentration and the molar mass. All right, that'll do it. Bye-bye.